Hello everybody and welcome back to another Bentley Davey Tutors video. Today we will be looking at how to do recurring decimals using algebra. And I'm very sorry that I have not worn a suit today. It's because Luke, in an attempt to escape, when Luke tripped over, he accidentally put a knife through my suit, so I wasn't able to wear it. But that's alright, I'm sure this will be acceptable. So in today's video I will be looking at how to do recurring decimals using algebra and how to turn them into fractions. And hopefully this will be useful. If it is, make sure to like and subscribe and leave a comment if you want to. You don't have to, but yes, that'll be good. Okay, now onto the video. So the first section of today's video will be algebra and recurring decimals. So this is a pretty cool trick that you do need to know for recurring decimals if you are ever asked to calculate recurring decimals as a fraction, which you often are. So let's firstly explain what a recurring decimal is. So a recurring decimal is any decimal that repeats on infinitely. So this could be something like 0.33333333 forever, or 0.7878787878 or whatever. That doesn't matter. So that's what a recurring decimal is, but basically that goes on forever and it repeats in the same way. So for example, while pi goes on forever, the numbers don't repeat. So it doesn't go on, that's not a recurring decimal. So how would you write a recurring decimal as a fraction? So with that example of 0.33333333, we most commonly know that that is equal to 1/3 or 1/3. But if you have a recurring decimal of 0.178 where the 78 repeats, so it's 0.17878787878, that's a bit harder to work out from your head as to what sort of fraction that is. So how do we look at doing that? Well, there's a cool method that we can do here where we use algebra to properly calculate these equations. So what we do is we let x be the original recurring decimal that you were given. So again, I'll use this 0.31. So if it's 0.3 repeating, x is equal to 0.3 repeating, or 0.33333333. Then we say 10x is equal to 3.333333 because it's just x times 10. So then we've got 10x is equal to 3.3 repeating, and x is equal to 0.3 repeating. And so what we're looking for is when both of those two have the same ending, or the same decimal. And now that applies here, but it applies a lot more in some of the harder questions. So as we can see, after you look for what's after the decimal point. So x is 0.333333. After the decimal point is the 3333333 bit, which is the same as in the 10x, where after the decimal point there is also 3333333. So that means that what we can do is we can use the nice little equation of 10x equals x plus 3. And how we work that out is we go 10x is equal to the x that we had there, plus the difference between x and 10x. So we know that the way to get from 0.333333 to 3.333333 is to add 3. So that's where our plus 3 comes from at the end. So we now end up with 10x equals x plus 3. So we use some algebra to solve this. We take an x off both sides. We now have 9x equals 3. And we find out that x equals 3 on 9, and then x equals 1/3. That's our answer there. That's a good one, but we're going to go on to the next one because that's quite an easy example. Our next one is 0.26, where the 2 and the 6 repeat. So this is a bit of a harder one. I personally don't know what 0.26 repeating is as a fraction, but we're going to solve this in the same way. So we're going to let x be 0.26262626, and then 10x will be 2.62626262. Now, we could do it the same way as before, except we can't, because let's have a look at these two numbers. 0.262626 has a different ending to 2.62622626. So they don't have the same ending. So we've got to go up another one. So we've got to go to 100x, which is equal to 26.26262626. So that's now got the same ending as before. Great news. So now what we've got to do, 100x equals x plus, this time, 26, because again, the difference between 0.262626 and 26.262626 is 26. So we've got now 100x equals x plus 26. Take the x off both sides. 99x equals 26. X equals 26 on 99. So that's how to turn that recurring decimal into a fraction. Now, our final example is the recurring decimal of 0.178, where the 7 and the 8 repeat. So we see here that x is equal to 0.178787878. 10x is equal to 1.78787878. And so we see there they have a different ending. So you can't do x and 10x. We look at 100x, which is 17.87878787, which is a different ending to the other three. So again, you can't do that. So we have to go all the way up to 1000x, which gives us 178.7878787878, which is the same ending as 10x, which, as a reminder, was 1.78787878. So now what we've got is 1000x is equal to 10x plus 177. Once again, we get that 177 by so 177 added to 10x is equal to 1000x. And so then all we need to do after that is take that 10x off both sides. We go 990x equals 177. So x equals 177 on 999, which means that x is equal to 59 on 33. I know I'm very good at simplifying in my head. So that is all we need there in terms of recurring decimals into fractions using algebra. Hopefully the example questions there were easy. No, not easy, were helpful. And if you need a couple of other questions, I'll just give you some random decimals right now and get you to, I don't know, solve them. So we'll start off with, I'll give you three. So 0.4 repeating, I want the answer to. I also want the answer to 0.68, where both the 6 and the 8 repeat. And I want the answer to 0.129, where only the 2 and the 9 repeat. Just for reference, you don't actually need to give me the answer to those questions. Those are just some that could be good if you are going to do some more practice. And if you do solve them and you want to know if you're right, bad luck, because we're not going to tell you, but I'm sure you can Google it. So thank you everybody for watching. Hope you enjoyed. Leave a like and subscribe, and stay tuned for more maths videos, because we have a maths test coming up, and I'm sure you might want to know some of the other topics that get covered in the Year 9 curriculum. So thank you and goodbye.